So starting with Newton's law, first one, object at rest stays at rest unless acted on by a net force. So that means that if I have a constant velocity, then I do not have a net force. It's just continuing because that is what the law says. Second law is A equals F net over M, or also F net equals mass times acceleration. It's the same thing. And that acceleration will always be in the same direction as the net force. So whatever direction your net force is, that's the direction of my acceleration. Every action has equal and opposite reaction. So how I think of this is the force of A on B has to be equal to the force of B on A. Whatever A is, whatever B is, doesn't matter. If it's talking about like my hand on the table and the table on my hand, that is a pair. It doesn't matter if they're at rest, they're accelerating, constant velocity, what? Those two have to be equal to each other and in opposite directions. And again, it's between the same two objects. I can't say that my hand on the table and the table on the wall. That's not a pair then. That's not necessarily equal to each other. If the object is at rest or if it's at a constant velocity, that means the forces are balanced. That means my net force is going to be 0 and my acceleration is going to be 0. When we're talking about force of friction, we have two types of friction. We've got static friction and kinetic friction. So kinetic friction is for if the object is moving, so once the object is in motion. If it's moving, then we're talking about kinetic friction, and this one is just straight equals mu Fn. That's why kinetic is the easier one. Once it's moving, that kinetic friction force is just always going to be the kinetic friction coefficient times the normal force. Now, static friction is the friction force when it's at rest, so when at rest. The tricky thing about this is this one, it can be less than mu Fn, right? This less than or equal to is talking about for static friction in particular. So let's say I have a mu Fn with static coefficient of 90 newtons. That means that is the maximum static friction that object can have. I have to overcome 90 newtons in order for it to move and start. Once it starts moving, then it would be kinetic friction. So if I only push it with 80, that does not mean it pushes back with 90. It means it pushes back with 80 because it's still at rest. It would still be balanced. So it's like a limit. It's up until 90, and then once it overcomes the maximum, then it would be kinetic. For the systems where you have multiple objects, you draw a free body diagram for each object, write a net force equation for each object, and then when you're writing that, make sure you're always doing like bigger minus smaller force, so that your net force is in the same direction of your acceleration. And then you're going to have to usually substitute, get one equation for like t, for example, and then substitute that in for the other one. When we've got forces at an angle or like the hanging tensions that are at angles, we break the angled force into the x and the y component, and then we write a net force in the y direction and and the net force in the x direction, and then again substitute. If you're talking about the same rope, it's the same tension. If you're talking about a different rope, it's probably a different tension. Now for inclined planes, that's something like this or like this, it doesn't matter, it's the same thing. The normal force will always be perpendicular, the friction force will be parallel. It's not necessarily always up because it could be like pushing up and then your friction force would be down, but it's along the surface, whether it's up or down, depends on which way it's moving or if it's at rest. And then we have, of course, weight straight down, so we have to break up the weight. The weight that is opposite the normal force, that component of the weight will be mg cosine, and the component of the weight that is like down the ramp, whether it's like this or like this, would be the mg sine of the angle. Do not try and use this for breaking down like a force F. That is not the same thing. This is only for breaking down weight, breaking down your mg for objects on an inclined plane. Right, number 1, we've got a block of 3m at rest on a frictionless table, and a block of mass m is attached over the frictionless pulley. We want to determine the acceleration of this block when the hanging block is released, and leaving our answer in m, and physical constant just means g. So when just a note, when they ask you for a certain acceleration of like a certain object, when they're connected, it's the same acceleration. I just want the acceleration of the system. So we're going to draw our free body diagram for each. So the 3M's got normal, gravity, and tension. And then the M has got just gravity and tension. And then now we're going to write our net force. This guy is going to accelerate sideways. This one's going to accelerate down. So then my net force for 3M is just going to be T. My net force for this guy is going to be Fg minus T. And then now we replace. This was M, so MA equals Mg minus T. And this guy was 3M, so 3MA equals T. Now I have two equations. I'm trying to get A by itself. I have this equation, but either one I have T, and I'm not allowed to have T in my answer, so I'm going to substitute in. So that gives me MA equals Mg minus T, which is 3MA. Add that over, that becomes 4MA equals Mg. Divide 4M over, because we're trying to get A by itself. M's cancel out here, so this is just G over 4 for my acceleration. And that should make sense because I have this net force of Mg, right? The only force like accelerating the system is this guy's weight, and it's over the total mass of 4M, so that would give me Mg over 4M or G over 4. Number 2, we've got a box of mass M on a rough surface, which tells me there's friction. We've got a force of magnitude F exerted at an angle theta, or actually that's a 5, but it doesn't matter. As it moves, there's a frictional force, F, little f, which of the following is the net force? So first let's draw our free body diagram. We've got normal, we've got gravity, we've got this frictional force F, and then I'm going to go ahead and break this down. So I know that this F is pointing both up and to the right, because it's going up and to the right like this. So first let's do the one to the right. That would be adjacent to the angle, so that would be F cosine. And then the up part of it would be the y part, or the opposite, or the sine, so that would be F sine, like this. I want to know the net force. Well, it's going to be accelerating this way, so I'm just going to say my net force would be F cosine minus F, because they're in the separate directions, so then my answer is just A. If the angle was decreased, what would happen to the normal force? Would it increase or decrease? So think about, right now, my normal force is Fg minus F sine of the angle. Because if I take away this force, then my Fn would just have to be equal to my Fg. So if I decrease the angle, see how I'm decreasing how much of the F sine theta is holding up some of the weight? That would mean my Fn would have to increase to balance it out, so your answer was increase. We've got a push broom pushed across a rough surface. Again, that means we have friction. And the broom itself is pushed with a force of magnitude T. The coefficient is mu, and I want the frictional force. So let's first of all draw our free body diagram. I've got Fg, I've got friction going to try and go against, I've got my normal force, and I've got this T pushing down to the right. So I'm going to break the T up. So T would be down and to the right. So I look at my diagram, the part that is to the right, the sideways part, is going to again be my adjacent, so my cosines, that would be T cosine theta. And the part of it that was down, like this, is going to be my opposite, so that will be T sine theta. Two ways we could have gotten friction. We could have said that my net force equals T cosine theta minus the force of friction. That would be MA, and I could rearrange, except for I don't see MA in any of these, so let's use the other way. Force of friction equals mu Fn, and I'm definitely allowed to use mu Fn, because does it say it's moving? It doesn't. I meant to say this was moving. So for kinetic, we would be able to use mu Fn. So then I have my mu. Now it's just finding my Fn, so you would write your equation in the y direction. So Fn is just Fg plus T sine theta. So that's going to be mu Fn, Mg can replace Fg like this. And then your answer would be A. Number 4, we've got blocks A and B at rest on a smooth surface. Smooth meaning no friction. So I'm going to cross off this one. It says block B is glued to the table. Block C is suspended by a string that is tied to block B over an ideal pulley, which the following shows all the horizontal forces acting on block A. So obviously we've got gravity and normal acting on block A, but I want just the horizontal forces, which is why they're not included. So let's look. I've got tension. Tension is a pulling force, so it has to pull to the right. Both of them have tension to the right, so that would be my tension. And then now it's just this block B, or box B, which way is it pushing on the block, because a block can't pull, it can only push. So think about, we want the forces acting on A, so that means B is pushing A to the left, so it would be pushing back. So then your answer would be this one. Remember, tension is a pulling, blocks can only push each other. 5, we got an object that is moving south at a constant speed. As soon as you see constant speed, I want you to think balanced forces. I have 3 forces acting on it. I've got 15 newtons south, I've got 5 newtons west, and I want to know the magnitude and direction of the third force, and again, just one force that would make these go at a constant speed, which means balanced. So that means that if I had a force this way, right, it would not be balanced, it would definitely accelerate southwest. So I must have a force like this that will help balance out these 2 forces. So automatically we can cross off A and B because I know my third force has to be northeast to balance out the south and the west forces. Now the actual magnitude, well, I don't know what the magnitude is, but I do know the x component needs to balance out this x component. So see how this x component would have to be 5. I know that the y component of the force has to balance out the y component of this force down, so that means the y component has to be 15. And then if I have 5 and 15, and I'm looking for the total force, well, that's just Pythagorean theorem. So c squared equals 5 squared plus 15 squared. And then that gives me c squared is 250, so c, or the force I'm looking for, is square root of 250. Now, that is not any of my answers, but you can type in your calculator square root of 250, 10 root 5, 5 root 10, and see which one is correct. Or you can think about this as this would be 25 times 10. Only perfect squares get to come out of the square root, so when 25 comes out of the square root, it's now a 5. So then your answer is D. Or again, you always have a calculator on the AP physics test, so you could just see which one matches. Probably would save time that way. Alright, 6, we've got a ball of mass M accelerated up by a string that's pulling with the tension force T, so accelerating up, so bigger force. And then obviously gravity would be the opposite direction. I want the acceleration, so let's write our net force. Net force would be T minus mg. Net force is just ma. To get A by itself, we would divide the M over, and I had a lot of people in class go, Miss, that's not an answer choice. No, it's not, but something that is the exact same, or not the exact same, but is equal is an answer choice. Think about when you divide everything by M, that's dividing each thing by M. So T over M would just be T over M, mg over M would cancel out, so it would be T over M minus G or C. If I exert a first force F on an object, the force which the object exerts on you, so think about, this is you on an object, and the object on you. So, you on object, and object on you. This is a classic case of Newton's third law, because it is saying A on B, B on A, the same 2 objects, just flipped. So then your answer is going to always be F. Doesn't matter if it is moving at a constant velocity, if it's a rest, if it's accelerating, that force, those 2 forces are the same force, so they'll be equal. 8. So we've been given a lot of different things, so I'm going to label. I have 1,000 kilograms mass, initially traveling at 30 meters per second. Meters per second is a velocity, that's at the beginning, so I'll call that V naught. Driver applies the brakes suddenly.